Here we go. Again, just wait a second for that Elmo to turn on and kick on. We're going to go ahead and start up number 17 as soon as we get us a picture, which will be pretty quick here, I think. Here we go, here we go. All right, number 17. So 17 looks like this. R equals 2 plus 3 cosine theta. Again, from 0 to 2 pi. So if I were you, again, I'd pull out my theta and my r's, and I'd be going 0, pi over 6, pi over 4, pi over 3, pi over 2, and let's see if we can kind of come up with an idea of what this thing's going to look like. Plug in a 0. Cosine of 0 is 1. 1 times 3 is 3, plus 2 is 5. So it's 0, I'm at 5. So let's go ahead and draw up our polar graph. 1, 2, 3, that's a little wiggy. 4, 5. So we're out here at 5. Now if I put in pi over 6, cosine of pi over 6 is square root of 3 over 2, which is 0.866 times 3. That's got to be close to 2.7 plus 2, so approximately 4.7, probably 4.6, 4.5. You guys can figure that out a little better with your calculator. I'll let you do that in your calculator. So 1, 2, 3, 4, point whatever that is, so about right in there. So okay, we're coming in. Pi over 4 square root of 2 over 2, which is 0.707 times 3 is about 2.1 plus 2, so approximately 4.1. So at pi over 4, we're at 4.1. 1, 2, 3, 4. So now we're even closer to the 4 right there. At pi over 3, we're at 1/2 for the cosine. So half of 3 is 1.5 plus 2 is 3.5. So pi over 3, we're at 1, 2, 3.5. So now we're into there. And then at pi over 2, we're at 0. Times 0, 3 is 0, plus 2 is 2. So there we're right there. Okay, so there's our graph right there. Now we're going to go ahead. I don't feel totally confident what this thing's going to look like, so I'm going to go to 2 pi over 3, and then I'll go to 3 pi over 4, 5 pi over 6, and then pi. That should give me a pretty good idea. 2 pi over 3, cosine is negative 1/2, so 3 times negative 1/2 is negative 1.5, plus 2 is 0.5. So 2 pi over 3, which is here, I'm at 0.5, so it's like in here, so into there. 3 pi over 4, negative square root of 2 over 2, times 3 being like negative 2.1, plus 2 would be like a negative 0.1-ish. So instead of coming out that way, I shoot back this way a little bit, so it comes into here. Okay. 5 pi over 6, that's going to be a negative square root of 3 over 2, which is negative 0.866 times 3. It's going to be close to negative 2.7, plus 2 would be like close to negative 0.7. So again, now instead of going that way, I'm going to shoot that way. So I'm going to get a little bit even closer to that 1. Alright, so then a pi, which is negative 1, times 3 is negative 1, plus 2 is negative 1. So, negative 3 plus 2 is negative 1. So a pi, instead of coming this way 1, I come out here to 1. Okay. So this thing I think is going to do a loop-de-loop. I think it's going to do a little loop-de-loop on us. It's going to come back around. So I think it's going to loop up. It's going to come back around. And it's going to work its way back out to there. And it's going to look something like that. So that's how it looks. Go ahead and take a look, and there you got it. 18. Let's take a look at 18. Alright, so 18 says 2 comma pi over 6. We're supposed to graph these. So I'm going to go ahead and put our polar graph up right here. There's my one circle, 2, 3, 4, 5. Is anything above 5? Nope, so we should be good there. Alright, so I graph them. What I'm going to do, I'll go ahead and graph them in blue, see if I can make it a little better for you. 2 pi over 6. So that's on the second ring, and pi over 6. So pi over 6 is about there, and so 2 is like there. It's that one right there. 2 pi over 6. That's 18 right there. Okay, 18. Right there. 19. 19 says negative 3 pi over 3. So if that's true, so I go to pi over 3, which is now this one up here, which is like your 60-degree angle. But negative 3 says instead of coming out this way 3 circles, I go and shoot in the opposite direction 3 circles, and it's right there. There's number 19. So right there, so it's at pi over 3, but then instead of coming out this way 3 circles, the negative radius right here, the negative radius makes me come the opposite direction. Number 20. 2 negative 2 pi over 3. Okay, negative 2 pi over 3. If you count it out, negative 2 pi over 3 is this one here as well, because negative pi over 3 is here, and this is negative 2 pi over 3. So the second ring out, so it's right there. So that's number 20. Number 20 is right there. 21. 21 says negative 1 negative pi over 2. Okay, let me scoot that up for you guys a little bit. So negative 1 negative pi over 2. So negative pi over 2 is this line right here. This is negative pi over 2. Negative 1 says instead of coming this way 1, I got to shoot the other direction. So it's right there on that line. So that's number 21. Okay, let's look at 22. 22 says 4 negative 225 degrees. So negative 180, so this is negative 180 because it's just coming around this way. Coming around this way, negative 180. That means I got to go up another 45, so right there's negative 225 degrees. And I go out 4 rings, so 1, 2, 3, 4, there it is. That's number 22. Another option you do have, if you'd like, folks, is when it says negative 225, if you wanted to find the coterminal angle with negative 225, you could take negative 225 plus 360 degrees. And negative 225 plus 360 gives you 135 degrees, which that's this angle too. This is 135 degrees and negative 225. So if the negative 225 idea isn't working for you, you can always find its coterminal angle, 135, and you'll know exactly where it's at. Same thing with your pi's. You can always add 2 pi to it, and you get it. So if I took negative pi over 2 plus 2 pi, get a common denominator of 2. Negative 1 plus 4 is the same thing as 3 pi over 2. And look, this is 3 pi over 2, which is negative pi over 2. So just a coterminal angle, if you want to do it that way, you can. All right, let's finish this out. 23. 23 says we have point at 135 degrees. So this is 135 degrees, 3 circles out, puts me right there. That's number 23. Bam. 24. 24 says it's negative 250 degrees. So I go to 150 degrees, which 150 degrees is like right here. But negative 2 means instead of coming out 2 this way, I shoot in the opposite direction 2, so it's right there. That'd be number 24. And last but not least, 25 says negative 1, negative 30 degrees. So negative 30 degrees. So this right here happens to be negative 30 degrees as well, because I just came down 30 degrees. Then the negative 1 says shoot back that way 1. So it puts me right there on that guy. So there's 25. Right there. It's kind of a mess, but you can see them. You got them. All right. Let's move on to the next set. 26. Here we go. 26 says verify the following trig identities. So here we go. 26. We have secant of x times cotangent of x times the cosecant of x has to equal cosecant squared of x. So left hand side definitely looks like we can do more to it. So secant is 1 over the cosine. Cotangent is cosine over sine. And cosecant is 1 over the sine. So cosine and cosine will simplify, divide to 1. That's going to leave us with 1 over sine squared x, which is the same thing as cosecant squared x, which is exactly where we wanted to be. 27. 27 says sine theta plus cosine theta quantity squared equals 1 plus sine 2 theta. Please, 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 please write this out. So it gives me sine theta plus cosine theta times sine theta plus cosine theta. And that's going to give us sine squared theta plus sine cosine theta. Then cosine theta times sine theta is a plus cosine theta sine theta plus cosine squared theta. Sine squared plus cosine squared, that's the same thing as 1 plus sine theta cosine theta and cosine theta sine theta are the same things. So that gives me 2 sine theta cosine theta. And I know what 2 sine theta cosine theta is. That is the sine of 2 theta, which is exactly where I wanted to be. And we're done. Okay, 28. Here we go. 28 says secant squared theta over secant squared theta minus 1 equals cosecant squared theta. Now you may not remember this, but secant squared theta minus 1 is the same thing as tangent squared theta. I'm not anticipating you necessarily remembering that. So let's look at what we got. Secant squared theta would be 1 over cosine squared theta. You could write this on the bottom, secant squared theta minus 1, you could write that as 1 over cosine squared theta minus 1. Get yourself a common denominator, which of course would be cosine squared theta. That would lead us to 1 over cosine squared theta times, you're going to take this guy here, you're going to multiply by the reciprocal, which is going to be cosine squared theta over 1 minus cosine squared theta. These guys are going to simplify, leaving you with 1 over 1 minus cosine squared theta. But now 1 minus cosine squared theta is the same thing as sine squared theta. So that's the same thing as 1 over sine squared theta, which is the same thing as 1 over, or not 1 over, cosecant squared theta, which is exactly where we want it to be. And we are now done. All right, let's look at 29. So 29. You guys are going to have to tell me if you like these videos or not. I'm not sure if I like it this way or not. Let me know what you think, okay? Here we go. Trying to square up a little bit here. 29. So 29 says convert the rectangular point -3, 4 to polar coordinates. Give your answer in degrees. And we're going to use a calculator. So, first thing I have is I have an x and a y, and I want to go to an r and a theta. So I know r equals the square root of x squared plus y squared. I know theta equals the inverse tangent of y over x. So this says r is going to equal the square root of -3 quantity squared plus 4 squared. So that's going to be 9 plus 16, which is 25. The square root of 25 is 5. Oh yeah, if I would have drawn up the triangle, I would have totally seen that, right? -3, 4. Right up here is this point. There's my radius. Draw my line down. This is a 3, 4, 5 right triangle. 3, 4, 5. So there it is, 5. To get theta, I'm going to take the inverse tangent again of 4 over -3. Let me grab my calculator real quick. And it says that it wants it in degrees. So you need to make sure your calculator is in degree mode. Then you're going to take the inverse tangent of 4 over -3. That's going to give us a angle is -53.13. Folks, that's this angle down here. That angle right there is -53.13. I don't want this angle. My point is up here. I want the angle up here. So just add 180 to it, and you will have the correct answer. So add 180, and you should get 126.8 5.70. So my point is 126.870 degrees. Done with 29. 30. Let's take a look at 30. I'll scoot up a bit. 30 says convert the polar point for 115 degrees to rectangular. Okay, no problem. So this is r, this is theta, and I need to turn it into an x and a y. Remember, x equals r cosine theta, y equals r sine theta. Therefore, I get 4 times the cosine of 115 is my x value, and 4 times the sine of 115 is my y value. I just plug them straight into my calculator, folks. So I go, and it says that it wants it in, and those are degrees, so make sure you're in degree mode. So 4 cosine 115, and that is negative 1.690. Okay, and then 4 times sine of 115, and that is 3.625. And there's your answer. Now let's see if that matches up to what we're saying here. So if I'm looking at 415, 115 degrees has got to be about like right here. And then 4 would be on the 4th circle out. So approximately-ish, it's like right up there. Let's look at this point here, negative 1.69. So it's like out to here and then up 3.625. It's pretty close. So yep, it works. And we are done. All right. 31 wants us to graph them. Okay, you are welcome. 31 says graph these big bad boys. So we're going to take 3 sine of 4 theta on from 0 to 2 pi. So I'm just going to plug it on my calculator. Let's see if I can see if you can see my calculator here. You can. Sweet. So I'm going to go and first of all, I'm going to go to my mode. I'm going to change it to radians, and I'm going to make sure that I'm in polar. So I'm on polar and radians. Now I'm going to go back to my y equals and notice now that it's r equals. I'm now going to type in 3 sine 4 theta, and theta is just the x button. Okay, this button right here is theta, which normally is your x button. Now I'm going to go ahead and I'm going to zoom 6 it. So there it is, and then you know what? Wow, to make it look nice, I'm just going to zoom 5 it to get it square. And you can see that we got ourselves a nice looking flower right there with 1, 2, 3, 4, 5, 6, 7, 8 petals. Okay, looks to me like it's not going out too far, so I would just copy that. I would just kind of copy that sketch of the graph onto your paper. So I mean, you know, you're just gonna make it look kind of. In fact, let's even take a look again. I'm gonna zoom 5 it now. Watch this time as it goes. Watch where it goes. So it goes up, over, 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 over. Okay. So there you go. So it started here. Then it went here. Then it went here. It went here. 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 And then there. Sketched. Done. I know it's not pretty, but hey, it's okay. 32. 32, I go back to my y equals. It says that I want to graph 4 cosine. Now again, okay, I'm going to type in theta divided by 3. Now the deal is I got to change my window because they tell me the window's got to be from 0 to 3 pi. So the 0's there, but the 3 pi isn't. But now it is. And now I just zoom 6 it to start out with. And there's the graph. Oh baby. And then I zoom 5 it to make it look a little bit more square. And there it is. So Looks to me like it starts out on the 1, 2, 3, 4th circle out. And then it just did a little something like this. Then came back in. Oh, didn't quite hit there though. Hit more like that. Something like that. Okay. And you're done. 32 is done. Let's see how much more of this I have left. That's it, baby. We're done, folks. Hey, good luck to you. Sorry the videos were late. Let me know if you like this new format. If you don't, that's okay. Just let me know. All right, man. Good luck. A days tomorrow. B days 2 days. We'll see you guys later. Bye. I have to take a second to close this. Okay.